Hi, my name is Wes Thompson. I'm a professor of biostatistics at the University of California, San Diego, and I'm the director of biostatistics for the ABCD study, the Adolescent Brain Cognitive Development Study. Today I'll be talking about scientific approaches and tools in ABCD using the Data Analysis and Exploration Portal. From now on, I'll be referring to that as DEEP, the acronym. And so the purpose of today's session is to go through DEEP and to give you background on what it does, how to use it, and also hopefully at the same time give you a little bit of background about ABCD, the study design and the sample, and how to think about doing some analyses. So what is DEEP? DEEP is a web-based interface with cloud deployment. It's hosted on the NDA, the NIMH Data Archive. In fact, it's the same place where you would go to access the data, to access permissions for the data, and to actually download the data for analysis. So if you just go into Google and search ABCD DEEP, D-E-A-P, it's the first thing that'll come up. If you have access to the ABCD data on NDA, sorry for all of the acronyms. So again, NDA is the NIMH Data Archive. You will all automatically have permissions to use DEEP. So you can, once you get permission to use the ABCD data, which I think has been described in another talk. So I'm not going to go over it here, but once you have those permissions in place and you can download the data, then on the very same page where you access the data, you can also access DEEP. So that there's several nice things about DEEP that may make your life easy, and it may be a tool that you might consider using. Maybe not even all the time, but at least occasionally for certain aspects, or you could, end up using it for, like on a regular basis for different types of analyses. But I would recommend at least checking it out once you get access and taking a look through it. And if you think it'll be helpful to explore the data, to get a sense for what's in there, for some recommendations for how to analyze it, and so forth. I think that it's definitely worth checking out. So it's got a number of features. Like I said, it's a web-based interface. You can run it on your cell phone if you want. It should work in Safari or Chrome or whatever. You can interact with the data remotely. So you can do analyses and exploring the data without actually downloading the data. It's got recommendations for how to do analyses like built-in nesting for the design structure of ABCD, which I'll talk about a little bit later. It has built-in suggestions for the covariates you might consider using that also reflect the design of ABCD. And it has some visualizations and statistical summaries of variables in ABCD as well. So let me just kind of go through and give more detail. But before we move to DEEP proper, I also want to point out that we have other computational resources in pipelines that have been implemented in DEEP. I'm sorry, in ABCD. ABCD is a large, complex study with lots of moving parts. It's got, of course, brain imaging, which everybody already knows. It also has whole genome genotyping. It has geolocation measures of environment. It has questionnaires on neurocognitive tests and questionnaires on different topics, mental health and physical health, and so on and so forth. And a lot of the scripts that the ABCD Data Analysis and Informatics Resource Center has put together are available for download on ABCD GitHub. So here's the URL here. So it's github.com ABCD study. We actually even have the code for DEEP available. So if you wanted to create your own DEEP-like portal for a different study, the source code for DEEP is also provided on the ABCD GitHub. Also, all the scripts we have for processing the data is available on GitHub. So the analysis under -NDA 17, that was the script for merging all the files together for DEEP for the the 2.0 release. I'll go in a little bit more detail about what Deep does in terms of processing the data and how it's different from what's available on other parts of NDA a little bit later in the talk. So, but before I move on to Deep proper, I want to go over some aspects of the design and the release schedule for ABCD because I think it pays to be familiar with the design aspects of the study before you start analyzing it. So ABCD is intended to be a 10-year longitudinal study. We have public releases on an annual basis. So far, there have been 2 public releases, so like 2.5. There's an interim kind of like data patch and some extra measures. So there's a 2.0.1 release. We're in the middle of getting the 3.0 release ready. That'll be ready by the end of the summer. Probably in one of the other talks, they have more details about what more precise schedule is and maybe what the data are for that. But the general point here is that it's a somewhat complicated structure in the sense that for every release, and so the release year is on the rows here on the top of the figure. And the time points, the visit structure is across on the columns. And so you can see, for instance, if you go baseline year 1, at that point we had roughly 5,000 subjects collected, and it was only the baseline observations. In release year 2, so the 2.0 release, there we had it says 11,873, but I believe the actual number should be 11,878. But I think there was actually 11,875 in that release. So there's like a slight variation in the number, but like this is more or less correct. At that point, we had basically everybody from baseline. So like over 2 years of data collection. And so at that point we had all of the baseline assessments for everybody. And then we had some 6-month assessments on almost 9,000 subjects. So not the full sample, but on the majority. And then we had year 1 assessments on again roughly 5,000 subjects. So because of the timing, the people who had full baseline assessments at the year 1 release then had a year 1. Most of them had a year 1 assessment. These are all estimates, by the way. There's more precise numbers, if you go to the actual release now. And actually, one thing that is not true is I don't think there was any 18-month data in the 2.0 release. But again, the kind of the off year assessments, like the 6th month and 18th month and so forth, are very limited, not in person and telephone interviews. And so most of the time most people won't be using that data too much. It's the in-person visits on an annual basis that collect the vast majority of the data. And so then if you look on the bottom, you can kind of see visually the amount of data that's released. As you've probably heard in some of the other talks by now, there's 21 sites across ABCD. There's upwards of 65,000 measures per person in the baseline data. A lot of that is actually tabulated imaging data, so it's maybe it sounds more than it really is, but so in the NDA data files, they have all the like the ROI level data for T1 and T2 weighted images and the resting state and so forth. But there is a lot of data, especially on the every other year. So we have the baseline data, which is a full assessment with the brain imaging. And then year 1 data is, so if you look down below the baseline, you'll see that there's far fewer measures. There's only the little blue lines on the left side. There's still several thousand measures being collected if you process all the data out, but there's no imaging at year 1 because the imaging is every other year. So it's the baseline, year 2, year 4, year 6, year 8, year 10. Those are the visits that will have all of the imaging data. And for those visits, the files from NDA will be pretty massive because they'll have at least so far 65,000, and that'll probably creep up over time. And I just want to point out that does not include the genetics data. The genetics data are available on separate files in p-link format. So if you want the whole genome typing data, you can download that. It's already available on roughly 10,000 subjects, but the genetics data is not included in this display right here. So let me go to the next one. So here's a little bit more detail, the measures that have been collected over the first 18 months. So you can see the top is the baseline visit on almost 12,000 children aged 9 and 10. Again, a lot of this is imaging data, but there's also data from culture and environment, mental health, physical health, substance use measures, neurocognitive battery, some mobile technology, Fitbit data. Then of course there's the MRI scans, and then some passive data. Passive data is kind of a catch-all term. We've moved away from that term. It's more kind of geocoded data, geocoded environmental exposures, and that's something that's been expanding over time as well. And then you can see at 6 months there's very little data. That's telephone data, and then at year 1, there's still quite a bit of data, but it's much less because it doesn't include any imaging, and then so on and so forth. And so this is kind of a schematic for the 2.0 release, which is the current release. It's actually the 2.01 release. So now to get to deep. The rationale for constructing this tool was, well, as you've probably noticed from the past few slides, the data is large and complex, and there's a lot of data per kid. There's longitudinal data. There's some complications, like there's different sites. There's different, MRI machines. There's families. I didn't get into that, but there's a twin component. So there's a substantial number of twins, and there's also non-twin siblings and so forth. Roughly 4,000 of the 12,000 kids have a sibling in the study. So it's, these are things that need to be considered when you're doing analyses and when you're exploring the data. You can't just ignore site effects in hope that they, you can, but it's better not to. You certainly can't ignore family effects, when there's such a substantial proportion of the sample, and expect to get your degrees of freedom right in regressions, so, for example. DEEP was intended to kind of get people over the hump in terms of getting access to the data, figuring out what's available in the data, and then giving kind of a leg up on how to think about doing analyses, and even to start doing some analyses remotely. We're not saying that everybody will do everything that they want to do in DEEP with ABCD. In fact, I'm sure that's not the case for most researchers, but it's supposed to kind of lower the activation energy to get familiar with the data and to figure out what's in there, and to give some helpful hints on ways to think about doing your analyses. So here we have the splash screen. This is what you see when you first log into DEEP. And so on the relevant thing here is there's a little menu on the left, and each one of these is a link to a different resource. So getting started, basically, let me see if I have a slide for that. Nope. So let me just describe that. So getting started is mostly static. So it's just like description of some resources, some references to relevant papers, some background on ABCD. It also has updates on a regular basis. So the current version of DEEP, actually, we've been updating it semi-periodically with bug fixes and some enhancements. And so we currently have a link where you can see what's been done recently. By the way, we have a current set of enhancements that are coming out in the next couple of weeks, which I'll go over in a slide in a few minutes. Plan is potentially interesting. So here is basically resources for if you want to do hypothesis registration, which is becoming more and more popular. So I think some people are concerned that, with a data set like this, you can, like, with hundreds or thousands of variables, it's easy to kind of poke around and find significant relationships, and then to post-hoc write a paper that wasn't, a planned result necessarily. And so I'm not saying that's always a bad thing. If you're in exploratory analysis is a valid thing to do. But if you wanted to register hypotheses and do a planned set of analyses, to explore a specific question, in the plan module, you can access a template for registering your hypotheses on Open Science Framework OSF. And we give resources there and a list of journals that take pre-registered hypothesis types of papers. So I think that's becoming more and more popular, and more journals are publishing those types of articles. But the first component of DEEP that I'll actually go through in detail is the explore function. I personally find this useful even now. So here's what happened. Here's what you see when you click on that link. It basically, there's two components to explore. On the left side, we have an ontology and tree-based ontology, and on the right side, we have kind of a search function, like kind of a Google-like search function. And so I wish I could do this live because then you can see exactly what happens. But like basically the ontology splits the data out into a tree-like structure that reflects the work groups in ABCD. So there's a number of expert work groups that have topics that they focus on. So there's biospecimens, culture and environment, imaging, of course. Mental and physical health is now split out into two work groups. And so in the current version of, or the version of DEEP that's coming up, this will be split out into two nodes rather than one. There's the neurocognitive battery. There's the residential history derived scores. That's actually the geolocated data for geolocated exposures, substance use, and then summary measures are, I actually forget what those are. I think they're summary scales of different type. I can't remember which. But if you click on one of the nodes, it opens up the branches of the tree to more detail. And you can see the individual measures that are under the branches, and sometimes like they'll be several layers to the tree. So here you can see, if you click on demographics, it'll pop open some of the key socio-demographic components in ABCD. And just to let you know, for the design of ABCD, ABCD was designed to reflect the population of the United States as closely as possible. And so there was a within each of the 21 catchment areas, there was a random sampling of schools, and most of the subjects, not all, but most of them were recruited through schools. And the random sampling of schools, the set of schools in the list to be randomly sampled, was intentionally selected to reflect the population of the United States on some key socio-demographic categories. So of course we wanted to be balanced on male and female, but we also wanted to be balanced on race, ethnicity, household income, household education levels, marital status of the household, and a couple of others. And so even though the sampling wasn't perfect, there are departures of the ABCD sample from the population of the United States as assessed by the American Community Survey. They substantially did a pretty decent job. And in fact, in a later slide, I'll show you how to kind of account for the differences in our sample in the population of the United States in a way that you can try to get population valid estimates for parameters of interest. So, but in any way, continuing on with the explore function. So again, the ontology, if you click on these, this is dynamic, it puts up dynamic links. If you click on a variable at the node of one of the trees, it'll copy everything here over to the right side. And then it'll have a list of different variables here. If you click on the variable, if it's a continuous variable, it'll open up a histogram of the values and also the 5-number summary. If it's a discrete variable, if it's a categorical variable, it'll open up a little table which tells you the frequency within each of the bins. And so it's a nice way to kind of explore the data interactively. It also gives you the data dictionary entry for that variable, and then some of the variables actually have in the release notes have descriptions from the experts in the work groups, and we've tried to include those wherever possible as well in the on the right side here when you click on the individual variables. And you can also in the bar up here, where it says interview age now. You hear this, this an interactive search function, has Google-like as well. It's more not quite as good as Google, but like definitely kind of like Google-like capabilities. If if you type in a word that's commonly used for something like alcohol use, or you type in liquor or something like that, it should hopefully pop up things that are related to alcohol. And then so you can kind of interactively go back and forth between the left and the right side. And this is something that I find useful even now, because if like lots of times people say, well, is this variable in there or that variable, and with 60,000 variables, I don't know what every variable is in there. And so here I can go in and look at it and see, get the data dictionary description and see what the data look like, and so on and so forth. So I think this is a nice feature of Deep. This table here is actually in the, so let me go back a couple slides, is actually in the next link here called limit. And so what this does is, if you want to, I'll describe a little bit more detail what the data are in Deep and how it differs from the NDA or but when I get to the analyze functionality. But here in the limit page, you can basically determine subsets of the data that you want to analyze or look at or explore. So for example, here it says females only. And so if you do that, it'll tell you how many people fall in each of the categories, and it'll create a little a label, females only, that you can then port over to the analyze functionality, and you can then do your analysis, say, on just females only, or you could say like time point one only, or left-handers only, or right-handers only, or whatever variable you want to limit on. This I'm just going to say very briefly. There's the next. So I'm skipping analyze and going to extend. Extend is basically a way to create new variables using the current data. And so if you, for example, if you had height and weight in the as variables in the data set, and you wanted to create a variable that was BMI that you wanted to analyze, in this in the extend module, you can actually define your extension as a function of the existing variables, and then it'll show you the description of the data, and then you can carry that forward to the analysis as well. Another feature that we currently also have implemented is you can upload your own variables. So if you wanted to do a computation of something offline and import it into your analysis, you can actually upload that into Deep and include that as a variable in an analysis. So so here I'm going to talk about kind of the little bit more meat in terms of what Deep does for analyses. So if we go back to the homepage here, what I'm going to show you basically is what's in the third module, the analyze module. So if we go back here, this is what we have implemented. So just a little background first. So we have in Deep only the variables that are available in NDA otherwise. Almost. So there's no data in Deep that you can't get access to via downloading it directly from NDA. But if you've done this already, or if you do this in the future, what you'll notice is what you get is a whole bunch of text files, dozens or hundreds of text files, and then if you want to analyze different variables together, you have to merge them. They are text files, so if some of them are numeric and some of them are categorical, you'll have to go through and make sure that you define those appropriately in your analysis. We've done that already for everybody in Deep. And so what we've done, and those scripts are again available on ABCD GitHub, is we've gone through and extracted all of the data that's available from NDA, downloaded them as they are in NDA, merged them and put them together. We've given them more searchable names, names that kind of fit into this ontology tree-based structure in a more searchable format. So the Deep names, you can go back and forth between the Deep names and the NDA names, but I think the Deep names are easier to search through. And we've merged that, and we've created an RDS file, which is a data format for R. the R package, and we've uploaded that, and that's what we have available for analysis. We do occasionally also include other variables in the RDS file in Deep that are not directly available from NDA. So for a while there was like some family history, well, there still are family history variables, but they're all technically computable from the data that's already on NDA, but might require a substantial amount of effort. And so sometimes we'll add variables to the RDS file. And we always put the code for doing that on the ABCD GitHub. So if there's anything that we add to the RDS file that's not directly available from the other part of the other data on NDA, we make sure those scripts are available on ABCD GitHub also. So you could theoretically go through and do it yourself if you wanted to, or at least you can see where it came from and how it was processed. But the nice thing about the Deep here is that we've done all of this whole thing of like downloading the data, merging the files, making sure the data types are correct, and giving it a more searchable name structure. And so personally, I find that useful if I can start from like one RDS file that has everything in it already and it's already processed, and I don't need to worry about merging and stuff like that. That's kind of lowering the barrier for analysis, and lots of people kind of start their analysis from that file directly, and you can download the RDS file. So there's a link in NDA. It's a separate package. So you can download the RDS file, which is what's implemented in Deep. And so instead of going through and downloading all the files separately and merging them and whatnot, you can just go straight to that link, download it, and you'll have everything all together all at once. So I think that's a nice feature of Deep. And so now getting to the analyze functionality. So the backend for the analysis in Deep is R, and it uses that RDS file in the analyses. And so again, there's no data in Deep that's not available in the other part of NDA. It's just been merged, processed, and put together as an RDS file and directly analyzable in Deep. Sorry about that. So the model that we implement in Deep is a multi-level model. So it's a mixed effects model is another name for it. And it's implemented using the GAM4 package. There's nothing special about that. It just allows for smooth effects, and that's something that we can do in Deep. Let's look at like nonlinear smooth effects. But why use a mixed effects model? Because we have different levels of nesting in ABCD. So like I said, we have 21 sites. So we have nesting of subjects within sites. You could conceivably fit those as fixed effects, and that probably wouldn't make too big of a difference. But we also have, like I said, 4,000 subjects who are nested within families. So we have siblings. We have a lot of sib pairs. We actually have some triplets. We actually have one family of 5 that is like a set of, it's either a set of triplets and a set of twins, or 2 sets of twins and a singleton. But in any case, there's a lot of nesting of observations within families. And then going forward, and already to some extent, but like progressively going forward, we'll have nesting of observations within subjects because we'll have longitudinal data. And there's a lot of different ways you can handle nesting like this. But one of the most common ways is through multi-level or mixed effects models. And so what we have implemented in Deep right now is models like what we have here. Basically, we have covariates, for example, demographics, and we have recommendations for those. You don't have to use them, but they're recommendations. We have the ZSFI, independent variables of interest. We have, and then what's relevant for the random effects, we have right now we have a site-specific random effect, AS, and we have a family random effect nested within site, or so a BF of S. So, and then going forward, and actually we already do in fact have observations of subjects nested within, so time points nested within subjects, nested within families, nested within sites. And because this is a generalized additive mixed model, we also allow for nonlinear link functions like logistic link functions and so forth. So here is what the analyze page looks like. I'll just go through it kind of roughly. There's a lot of features I won't be able to go through because I'm not giving a live demo, but there are some nice features. We have independent and dependent variables. So you pick what, and this is interactive. So if you click on it, and there's a little plus symbol over here on the actual page, and you click on that, it'll take you over to the explore function, and you can kind of interactively decide which variables to put in your model. When you click on the variable, it'll open up a little histogram so you can see if it's normally distributed or if it's skewed, and then there'll be a little list of transformations that you can do, like a log transformation. For the independent variable, it allows you to do smooths or polynomial fits, and also I think for both the dependent and independent variables, you can do truncation if you have outliers and so on and so forth. So the independent variable, actually you can put in multiple independent variables and interactions and so forth. So there's sorry, this splash screen is actually a little outdated. It doesn't look exactly like this. Right, the dependent variable is on top. The independent variable is on the second row. And in fact, that's one that we use for basically for the primary variable for plotting purposes. So for plotting the results and plotting like effects across different levels of the variable. But you can also in the third line, you can include other independent variables, and you can include interactions and so forth. And then the row of variables here in green, race, ethnicity, gender, etc. These are some of the key design variables that I was talking about, where the ABCD is designed to match the population of the United States. And you can they're highlighted in green, meaning that they're automatically in your model. But if you click on them, you can click them off. So if you don't want these as covariates, then you can get rid of them. And then we have random effects of site and family. We've actually in our current version of Deep, we have an enhancement, so we can either have site or MR machine instance as an effect. Either one or the other. You have to have one or the other. We don't allow them to be put on at the same time because most sites have one MR machine. A few, like about half the sites have two, but they're largely multi-collinear. So if you're using the imaging data, we recommend you use the MR instance as your covariate. But if it's a non-imaging variable, then we recommend that you use site. So here's just some outputs. So we have these are all interactive. So like for instance, the points here are pickable. You can if you hover over them, it'll show you the basic information about subjects. So for example, if you have an outlier, you can see what characteristics they have. We have histograms, we have scatter plots, we have the fits with the 95% confidence intervals. We have parameter tables and ANOVA tables, and we have effect sizes tables. The effect size that we compute is the change in our square from fitting a model with the covariates of no interest going to the full model. And so we want to emphasize that you don't just want to focus on p-values. With a sample this large, your p-values could be quite tiny, but your effect sizes are also something you should look at, because a small effect size will give you a highly significant result. Doesn't mean it's not meaningful, but it's something to think about and to look at. So just a few more aspects of Deep. I know I'm running out of time. So there's a tutorial mode. So if you click on tutorial mode, it'll open up a bunch of text that describes why we're doing what things and kind of what they mean, and so what the outputs are and how to interpret the outputs. And so you can click on that and see what it looks like, and maybe from then on out you can click it off and keep it a little more compact. But at least there's some description as to what each of the different features is trying to do. There's also expert mode. So if you click on expert mode, it'll open up a window on the right, which shows you all of the R code that we're using to run the models. And you can actually edit the R code and make changes and define new variables and stuff like that, and then run it directly. There's also, you can download everything. Before I forget, everything is savable. You can save your session, so that if you, on the actual version of Deep, you'll see a little hamburger menu on the upper left corner. If you click on that, it'll open up a little box, and there you'll be able to save your analyses so you can come back to it later. You can share it with colleagues, or you can download everything. So, and what it downloads is the R code. It downloads all of the figures and plots, and it downloads the data that go into your model. So then you can take that and run it locally and use that as a basis to start doing your own analyses locally if you want to. Here's kind of a close up of actually this is the one I had in the previous page is out of date. This is what it looks like now. Actually, no, we have a little bit more now. So we also have the MR button and family ID button. Sorry, the subject ID button. So because now we also have longitudinal data. Okay, so let me skip to deep updates. Let me just kind of go through what we're planning on doing in the near future, and then I'll finish up my session. So we currently in our test version of Deep, which we're going to do beta testing for and get out in the next 2 or 3 weeks, we have a button that allows you to do population inferences that takes the inverse probability of sampling weights and applies them to the descriptive table of your data that's in your analysis, and also for the regression coefficients. There's improved download functionality using Explore, so you can kind of interactively determine like your sets of variables that you want to download. So if you don't want to download the entire RDS file, but just a subset of the measurements or a subset of the time points, we have an improved ability to kind of interactively determine which variables you want to download, and then you put that to a shopping cart, and then when you download it, you can download it as a CSV file, an RDS file, an SPSS file, or a SAS file. There's batch mode, which we're currently constructing, which will be ready soon. So if you wanted to run multiple analyses simultaneously, so for example, if you had a list of like 35 ROIs that you wanted to look at associations with, you could submit that all at once and run it in batch mode. The first 3 are coming soon, and then the next 4 are going to be in the next major update for Deep, which is the time to be about a month after the 3.0 release. That's at the end of the summer. So we're planning late summer, early fall for the next major update for Deep. And that'll include things like twin analyses using OpenMX, which is the package in R. And so that'll do heritability, univariate and bivariate heritability analyses using the twin data. We'll have enhanced capability for doing region of interest and image analyses and display of results. We're working on including a machine learning module, a comprehensive set of machine learning algorithms and cross-validation and so forth for analyzing the data using ML techniques. And then we're also going to improve the functionality in the display for longitudinal analyses, including spaghetti plots and enhanced interpretation of longitudinal change in the data. So that's my talk. Sorry, I went a little bit over. If you have any questions, please submit this to this link here, and I'm sure they'll get it back to me. And here, I just want to thank everybody who's involved, the NIH, a lot of institutes, primarily National Institute of Drug Abuse, but like a lot of other institutes too. Here's a list of all the different grants. I'm funded under the Data Analysis and Informatics Resource Center, the DRC, which is based at UCSD and led by Andres Dale. I'd like to thank all of our sponsors, and I think that's it. Thank you very much.
Hello, everyone. I'm going to be talking about novel technologies as they are applied in the ABCD study and the data that is going to be part of the upcoming release. So there are several advantages of applying novel tech approaches, which is why we are interested in this for ABCD study. So we know that we can have improved data collection efficiency, but low participant burden. We can capture data of participants in their environment, as well as but still working with youth in a manner that's comfortable for them, while still objectively measuring physical activity, sleep, mobile phone behaviors, and so on. And so we're really balancing the needs of ABCD to stay current with technologies that enable long-term monitoring, but really trying not to burden participants or staff. So there's 3 parts that I'm going to focus on in my talk today that's going to be part of the data release 3.0. So I'll start by talking about a screen time questionnaire, so that we developed a very comprehensive measure that's novel for ABCD, and we started this at baseline and have continued to use it during year 1 and year 2 follow-ups from both the child and the parent. Next, I'll talk about the Fitbit data. So we've collected data using the Fitbit from a pilot study of about 150 participants. And we've also rolled that out into the year 2 follow-up. So we get data including physical activity, sleep, and heart rate. And in the third component of my talk, I will discuss passively collected data on mobile phone usage. That's using a pilot app study in 75 participants with Android phones in the ABCD cohort. So starting with the self-reported screen time behaviors, at baseline, we added a screen time questionnaire for both youth and parent. And at year 2, we have extended and expanded on the questions we're asking. So we, for example, are looking at social media and social media addiction, asking questions like, which social media site do you use the most? I've tried to use my social media sites or apps less, but I can't. We also ask questions about video game addiction and mobile phone involvement questionnaire from Walsh. For example, I interrupt whatever else I'm doing when I'm contacted on my phone. And we finally added some questions around technology use during the approach to sleep, so around bedtime. For example, we ask, what do you usually do with your phone when you're ready to go to sleep? We also added some questions to the parent questionnaire about the youth's device use and behaviors. For example, if my teen has a bad day, I let him or her have screen time to feel better. Shown in this screen, in this slide, are some examples of the data that's coming out. So the top 2 slides show baseline and year 1 on 2 of the categories of screen time. So the number of, showing the number of participants, breaking down the categories of weekday video games and weekday texting as being 0 minutes, less than 30 minutes, 30 minutes to 1 hour, 2 to 3 hours, or 4+ hours. We have made some changes to this questionnaire at year 2. So we've changed from categories to continuous responses. We've added a question about total screen time use, which is a continuous measure. And because of these changes, we've also created a harmonized variable to allow us to continue to compare across years. So you can see on the right figure, the sort of a total view of what we have. This is the total screen time on weekdays. The parent single item is consistent across the years. We have the youth category sum, where we've summed up the amount of time spent in each of these different categories, like video games and texting. Then in year 2, we still have a category sum for total screen time, but we also have this harmonized variable to allow us to compare across years, where basically we've taken those continuous measures and recategorized it into the existing categories from baseline in year 1 so that we can continue to compare over time. We also have the youth single item, a continuous measure of total screen time. And just note that this is lower than the sum of all the categories, which is probably because sometimes kids will be using different types of screens or devices at the same time, so simultaneous use. So it's not necessarily equivalent to the sum of the categories of use. So an important point to keep in mind when analyzing the data. We really in ABCD are interested in getting full and complete measures of the kids' behaviors, and we understand the importance of objective measures. We know that physical activity and sleep are important determinants of health in children and adolescents, and that we need objective data to understand those relationships with mental and physical health, as well as brain development in youth. There are existing gold standard tools for tracking activity, sleep, and heart rate, and these are widely used, but they're not really feasible for a study that is as large as ABCD. So we turned our attention to consumer level trackers, which allow for multi-sensory continuous data collection, but they have a low cost and are non-invasive. Now, our first focus or first question was, are the wearables a valid option for tracking daily activity and sleep in our ABCD cohort? Shown here is just the summary data from several studies across the years, sort of ranging from 2014 onwards, looking at how valid are these wearables compared to gold standard measures. And in this particular diagram, it's showing the validity of wearables compared to polysomnography in tracking sleep-wake behavior. The wearable results are shown in the black dots and actigraphy is shown in the yellow dots. And we can see that in the top part of the figure, the sensitivity of wearables in tracking sleep is very high. The specificity in tracking wake is lower, although there has been some improvements in the second generation wearables where they are multi-sensory. There's this improvement in specificity. We've also focused on our particular sample, understanding that we have children, 9 and 10-year-olds and onwards, and we've done our own validity study, seeing whether the Fitbit Charge 2 device is valid in a sample of children, and we've found adequate results. The next step then for the ABCD cohort was to conduct a pilot study to determine how best to roll out the Fitbit and use it, and also how to work with the data in ABCD. So for the pilot, we enrolled participants at 3 sites. There were 50 participants at each site. They wore the Fitbit for 21 days. At this stage, they were 9 to 10 years old, and we used the Fitbit Charge 2 device. We found that there were some issues during data collection, such as lack of syncing, insufficient number of valid wear days, missing data. So considering these issues, the end result was a total of about 133 participants with what we would consider valid and sufficient data for use. We really paid attention to the issues that we came across during this pilot, during the data collection, and we've made improvements. So when rolling out the Fitbit in the year 2 protocol, we have improved and automated the tracking the Fitbit syncing and the wear and the charging, and we've developed an alert system to remind participants about their Fitbits. Now, the second factor that we have to consider with collecting this Fitbit data is what to do with it. There is a lot of data collected with the Fitbit. It's almost continuous for 3 weeks. So definitely need to consider, what do we do with the data? So we have a group of experts led by Ron Yang, David Wing, and Job Godino at UCSD, who have been going in depth into quality control, looking at the pilot data set so that we know better how we can apply the best practices developed during this pilot to the 2-year data and beyond. And at the same time, they've created a data processing pipeline for this data, which is including minute level heart rate, number of steps, the metabolic equivalence of task, which is an indicator of exercise intensity, as well as time spent in the sleep stages, which are at the 30-second level. The workflow is represented in this figure generated by Ron Yang at UCSD. Our starting point is the data that comes through a third-party data aggregator called Fitterbase. The data in its rawest form is forming part of the 3.0 data release that is available for the community to use as they wish. But at the same time as that, we've also worked our data sort of quality control process on the data to determine summary variables that are being released along with the raw data, applying our best practices. So what are those best practices? So the group of experts has evaluated heart rate, step, MET data, as well as the sleep data and missing data, and determined various best practices, including noticing that a lack of a heart rate value is strongly indicative of non-wear. So that is computed separately for day and nighttime. And we could recommend excluding these minutes. We also have identified identical heart rate values that are repeated for 10 or more instances, and we recommend excluding those since repeating heart rate reflects non-wear or disrupted wear. We also check if there are at least 600 minutes of non-sleep wear and at least 300 minutes of sleep wear per day, which we consider to be a necessary amount of minutes in order for analysis of that day to be done. And remembering that the data is collected for 3 weeks, it's also possible to aggregate the data per week. And for that, we recommend having at least 3 weekdays and at least 1 weekend day for a weekly aggregate to be made. Finally, we are using the sleep data. We recommend using the sleep data to measure day-night time for each participant instead of the arbitrary clock time. So the summary Fitbit variables that are available in the 3.0 release are related to physical activity, shown on the left, and sleep variables on the right. These are per day when there is sufficient number of minutes available. We provide the minutes excluded, as well as the reason why those are excluded, the number of steps, and then sedentary behavior, light activity, moderate activity, and vigorous activity. We also have the sleep data, including bedtime, the time taken to fall asleep, the time spent awake within the sleep window, as well as the time spent in light sleep, deep sleep, REM sleep. We also present the heart rate data averaged per sleep stage. When there are sufficient days available per week, then that data is summed and averaged for physical activity and sleep variables for those weeks. The next couple of slides, I'll show some of the data so you can see examples of what it looks like. Shown here on the left is the total number of minutes of data available as determined based on having sufficient, having heart rate data, showing the total minutes as well as the total sleep minutes in the light blue. On the right is a figure showing for each variable the average, minimum, and maximum. For heart rate in the blue, average step counts in the light green, and the METs in the dark green. And you can see from the maximums for all of these three variables that there is a lot of variability between participants, probably reflecting the variability in activity across the day between our participants. Here are a couple of figures showing the data from the nighttime, from the sleep period. So this shows the average wake time. This is in weekdays. So the wake time, the time spent in light sleep, REM sleep, the dark green is showing time spent in deep sleep. And then we have the total number of minutes spent asleep in that period. On the right is the heart rate recorded during the sleep time period. So the average heart rate, the minimum and the maximum, and average heart rate as expected is lower during sleep than during wake, and there is less variability during this time period. Now, what to do with the data? This is a wonderful, rich data source, and there's many analyses that can be run. Dr. Kara Bagott from UCSD has begun looking at some of the data, and here's just a comparison between weekdays and weekends. The number of steps and METs per day is lower on weekends compared to weekdays. Looking at the heart rate and the sleep, those are not different in this pilot data set on the weekdays and compared to weekdays compared to weekends in our ages 9 and 10 cohort. Amy Goldstone from SRI International used the data in a different way. So she was looking at the pilot sleep data and looking at categories of sleepers based on their total sleep time, where short sleepers were defined as being less than 8 hours of sleep, and then looking at three categories, 8 to 9 hours and 9 to 11 hours. She then looked at the bedtimes, which is shown here on the left, and found that the group categorized as short sleepers were going to bed later on both weekdays and weekends. So that was curtailing their sleep period. And they had a shorter time in bed. This data shows the weekends, basically reflecting that they have a shorter time period in which to sleep. She Then related the total sleep time with various measures on the child behavior checklist to relate sleep with other data within the ABCD data set. She looked at total sleep time, looking at whether it was averaged weekends and weekdays, or whether it was separate for weekends or separate for weekdays, and relationships were very similar. Shown here is the relationship between the average total sleep time and depression symptoms on the left, showing a significant relationship with the shorter sleep time relating to higher depression symptoms, and shorter sleep time relating to more externalizing symptoms. And this was after controlling for sex, race, ethnicity, SES, and age. So this was an exploratory analysis showing how the Fitbit data can be related with other ABCD data. And this was again using the pilot data set. As part of the release 3.0, there is also data coming from the 2-year follow-up in a much larger sample. Now turning to screen time, we know that youth use of digital media has skyrocketed in the last decade. And there's still unclear effects of use of digital media on brain and cognitive development. There's some indication that it can be a risk factor for depression, anxiety, and suicidality. Although we know that screen time, not all screen time is the same. There's differences between passive and active screen time, for example. And we know that parents certainly worry that their teens spend too much time on screens, but self and parent reports are inadequate. And there is a need for objective passive measures of screen time. So we recognized that in ABCD and proceeded to see if we could monitor it. And as for the Fitbit, we approached this with first running a pilot study, which then allows us to determine best practices that can be applied when we roll it out to the full cohort. So the aims of the pilot were to determine the optimal platform for ABCD's objective assessment of mobile phone usage and calculate things like average screen time, social media or other apps used, as well as time spent on the apps, and to be able to correlate those objective measures with self-reported retrospective questionnaire data, and to consider that we would want to correlate these objective data with the other aspects of ABCD, so mental health, cognitive functioning, brain maturation, to better understand associations between app usage and development. So the pilot study was really spearheaded by Tasha Wade at UCSD. The pilot data was collected on 70 participants across 3 sites, and these participants were all Android phone users, and they used the app for a period of 4 weeks. We derived several summary data variables that are part of the data release. Those include average daily use, total use by categories, for example, games, social media, YouTube. And we also gave the participants a questionnaire to determine things like acceptability of passive assessment and other measures of their experience using the app. In addition to the summary data being released, all the raw data is released, and these can be used for tracking time of day differences, as well as measuring specific applications like TikTok, and assessing variability over the course of a month. Here's a couple of questions that track the participant feedback. On the left, in your opinion, do you think that the amount of time you spend on your device is healthy? We found that majority thought yes. On the right, we see that most of them said they did not change their behaviors or their use of their mobile device while having the application on the device. Although do note that 41% said that they did change their behavior at least a little. So I think this reflects the importance of adding participant questions about the app and considering this when analyzing the data. Here's an example of some of the data that comes out from the app. This is the daily phone usage, so average daily minutes per participant on the x-axis, according to different categories of phone usage. So communication, gaming, music, news, and so on. You can see the wide variability between participants and also across the different categories. We can drill down deeper and look at specific app usage according to these different types. So here is communication types, ranging from emails, phone calls, SMS, social media. We can see, maybe not surprisingly, that in this group, the Snapchat and Instagram are used most across the communication apps. Here's another example of the data that can come out. This is showing average total screen time use according to time of day. We can see that the most use, or total screen time use, is in the evening, and to be expected, the least use is during the period when presumably they are sleeping. The average phone usage per day, as recorded with the app on weekdays, was about 3.5 hours, and weekends it increased to 4.7 hours, so increasing about an hour. When based on the self-report retrospective questionnaire, participants reported a lower usage, so 2.9 hours in the weekday, 3.8 hours in the weekend. So while these numbers are different, though, they did correlate, with the correlation being stronger on the weekdays than on the weekends. So where do we go from here? Now we've used this pilot in ABCD to determine that we can passively monitor phone usage in our sample. And so our plans are to roll out the phone app across the ABCD consortium in year 4. It would be offered to all participants with a phone. While we cannot get as detailed information from those with iPhones, we can collect limited data, so we plan to do that. And just bringing back the novel technology into context with the rest of the ABCD data set. Our aim here is to incorporate novel tech in ABCD to complement and supplement what we are focusing on in ABCD. So the data that is collected from the annual visit on, for example, the neuroimaging, neurocognitive function, we want to make sure that that data, that the novel tech data, can be related to the bigger data set. So that is why the plan is that we would collect the app usage data on the phones in relation to the annual visit, as well as to coincide with the Fitbit data collection. Yeah, we are always looking for new ways to expand or to add important measures in ABCD, and possible longer-term future options include light ecological momentary assessments, or EMA, to assess behavior changes and mood, as well as possibly looking at GPS-based assessments of activity. So I want to end by really saying thank you to our ABCD families and child participants, without whom collecting this data would not be possible, as well as our funding agencies from the National Institute of Health and additional federal partners. And thank you so much for attending this educational session of what to do with ABCD data and what to expect in the next data release. And we hope that you take advantage of this really rich data set that is available on child development. You can send us any of your questions to the address below. Thank you so much for your attention.